Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to learn algebra. Today is our lesson number 98. Lesson number 98. From day number 86 through 100, we've been learning how to solve linear equations. We are at day number 98. We have 2 more days to go before we finish this topic. Let's see what we have for today. The equation that we have for today looks something like this. X plus 3 over 9 plus x minus 5 over 5 equals x minus 11. That is the equation that is given to us. Our job is to decipher what value of x must it be that will make this equation tick. Yes, I know sometimes I come up with original ones, don't I? So let's do that, alright? First thing first. We notice that this term has a denominator of 9. This term has a denominator of 5. And if you like, if it makes it easier, let's pretend this entire thing as one term. This term has a denominator of 1. Even though technically speaking, this x is by itself and 11 is by itself. Even in that case, we can still speak of the fact that x has a denominator of 1 and 11 has a denominator of 1, because 11 is just 11 over 1. So they all have different denominators. Before we can do any work at all, they have to have common denominator. What will be the common denominator when you have a 9 and a 5? Well, it will be 45. That's the only way to do it. 9 times 5. How do we make this into a denominator of 45? A 9, how can 9 be converted into 45? By multiplying the top and the bottom by 5. How do we convert this 5 at the bottom into a denominator of 45? By multiplying the top and the bottom by 9. How do we convert this 1 into a 45? By multiplying the top and the bottom by 45. Voila. There you go. There's a multiplication sign here. It's getting too crowded. I don't like it. I'm going to rewrite it. X minus 11. Remember it. Except now the x does not come out as my usual x. I put that as a multiplication sign, didn't I? When I write x, I do not lift my hand. And when I do multiplication sign, I lift my hand. Alright, so that's it. Now everything has a denominator of 45. 5 times 9 is 45, 9 times 5 is 45, and that is 45. Since every single term throughout the entire equation has the same denominator, we can ignore the denominator. That denominator no longer plays any role at all. That denominator plays no longer any role at all. For example, 180 divided by 45 minus 90 divided by 45. Would you agree that it equals 2? I hope you do, because you see, twice of 90 is 180, and 90 we know is 2 times 45. Think of this as a 45, 45, 90 triangle, an isosceles triangle. 90 is 2 times 45. That's why it's called 45, 45, 90. Because 45 plus 45 equals 90, and 90 plus 90 will give you 180. Anyway, that's not what we're here for. So 90 divided by 45 is 2. 180 divided by 45 is 4. 4 minus 2 gives us 2. It is a valid equation. But this guy has a denominator of 45. This guy has a denominator of 45. This guy has a denominator of 1. How do we make this guy into a denominator of 45? Multiply top and the bottom by 45. Voila. Multiply the top and the bottom by 45. So basically now what we did was, we had a 2 and we multiplied the top and the bottom by 45. We haven't changed this value. 2 is still a 2. We cannot change its value. Whatever is given to us, that's the way it has to be. We cannot start modifying the problem. We haven't done so. We have not modified the problem. it is still a 2 because 45 over 45 is 1, and any number times 1 is the number itself. It hasn't changed. This is 2 over 1, and nothing has changed. Now, because of the fact that 45 appears in this term, and that side over here, because 45 appears in the denominator of every single term throughout the entire equation, it has lost its significance. It has lost its meaning. We can ignore it. If we choose, we can ignore it. We can ignore 45 altogether. 180 minus 90 equals 2 times 45. Nobody's going to argue with that. It is still a valid equation. 180 minus 90 equals 2 times 45. It is a valid equation still. That is what we're going to do here. We're going to ignore the 45 in the bottom. So what we end up here is 5 times x plus 3 plus 9 times x minus 5 equals 45 times x minus 11. Five times x is 5x, 5 times 3 is plus 15, Nine times x is 9x, positive 9 times negative 5, positive 9 times negative 5 is negative 45, equals 45 times x is 45x, and then positive 40, this is a positive 45 times a negative 11 is negative 45 times 11. Leave it like that for the time being. Don't worry about what that is. First thing first, we have a 5x and a 9x. 5x plus 9x make a 14x, and then we have a positive 15 and a negative 45. A positive 15 and negative 45 give us negative 30, and here we have 45x. It looks like we have no choice but to figure out what 45 times 11 is, because we're going to have to manipulate this thing, but which is very easy, which is not that difficult. 45 times 11 must equal 45 times 10 plus 45 times 1. 1045 and another 45 should be 1145. We need to figure out what 1145s are. Well, we know 1045s are 450. That's very simple. 1045s are 450. Plus another 45 should give us 495. So that's 495 right here. Minus 495. But do not reach for the damn calculator. Leave it alone. Leave the bloody thing alone, okay? Now, let's bring this negative 495 on this side. Let's add 495 to both sides. And let's subtract 14 from both sides. Let's subtract 14x from both sides. We're doing two steps together. A positive 14x and a negative 14x drop out. Positive 495 minus a 30 should give us 465 equals, again, a negative 495 and a positive 495 that drop out. 45 minus a 14x, 5 minus 4 is 1, and 4 minus 1 is 3. 31x equal 465. We need to get rid of this 31. Let's divide both sides by 31. So this 31 cancels out with this one. And now at the very end, in the last step, we're going to honor the tradition, we're going to honor the convention, which is to always write the unknown quantity on the left hand side and write the known quantity on the right hand side. So we're going to figure out what 465 divided by 31 is and just put it on this side, and it will be fine, instead of having to worry about it in the process. Just keep on going, keep everything positive. You see, we could have For example, we could have brought this 45x to this side, but had we done that, the x would have ended up with a negative coefficient. I don't like x to have a negative coefficient. It makes it much easier for us to keep it positive. The coefficient of x should be positive. Or shouldn't be. It's not that it should be, but it makes it easier. What is 31? What is 465 divided by 31? Well, let's find out. Well, we know that 30 times 15. We know that 30 times 15 is 450. Ah, there you go. 30 times 15 is 450. This is 465. We are 15 off, which makes sense because then 1 times 15 is going to give us the 15, making it a 465. So there you go, there's your 31. There are 15 of them. There are 15 31 make 465. I'm going to say it again. 1531 make 465. And how do we know that? Because 1530 makes 450. And 15 ones will make 15. 450 plus 15 will give us 465 that we're looking for. The very last thing that is left for us to do is to make sure that this value that we arrived at, the value of x being 15, make sure that it works in the equation. Make sure that this equation is satisfied by this value. Or in other words, another way to say the same thing is, make sure that x equals to 15 satisfies this equation. And in order for us to do that, it is a good idea for us to go back to the equation in its original form, revert to what it was originally, which is get rid of this 5 over 5, get rid of this 9 over 9, get rid of this 45 over 45, get rid of this thing. This is the original equation. X equals 15, so this side is 15 minus 11, this side better equal 4. One more time, since we just found that x is 15, 15 minus 11 is 4. So this thing better work out to be 4. Let's find out whether or not it does. X equals 15. 15 plus 3 is 18. 18 divided by 9 is 2. Oh, since we need a 4, if this is 2, this better be 2 also, because 2 plus 2 is going to give us 4. X is 15. 15 minus 5. 15 minus 5 is 10. 10 divided by 5 is 2. What do you know? Voila. Everything works out just fine. Everything works out just fine. Things are peachy. I don't know where they come from. I don't know where I picked them up. I hate that, just do. Peachy. I will see you tomorrow. I hope I used it correctly. I'll see you tomorrow on day number 99 on the penultimate day. Okay? Let's learn this word before we call it a day today. Tomorrow we have learned this word many a times. It does not hurt to learn it one more time. This is the E. P-E-N is spelled P-E-N, and then ultimate, but it's not pronounced penultimate. It's pronounced penultimate. What does it mean, penultimate? Let me use it in a sentence one more time. What I said is that today was our day number 98. Tomorrow is day number 99, our penultimate day for the topic that we are on, which is the linear equation. Penultimate is just a very fancy way of saying second to the last, because day number 100 will be our last day on the topic. Penultimate. Let's see if I can find my P's and see which day it was. Day number 11. Day number 11. And for those of you who do not know what I'm doing here, what I'm trying to explain to you here is that in addition to this algebra video that you're watching just now, if you're interested in improving your geometry skills, you can do the same thing. I have videos on YouTube which teach you geometry. Just type in the same tag, Keshwani Prep -geometry -day, whatever day that you want, and you will learn some geometry. So far I have taped 30 days as I speak today right now. Similarly, I have put together some videos which will help you improve your vocabulary, particularly the words that you are likely to see on any of these tests. If you're thinking about sitting for any of these tests in the near future, the GRE, the GMAT, the SAT, or the TOEFL. Again, the tag that you want to use is Keshwani Prep dash vocab, not vocabulary, just vocab dash day 11, and you will learn this word penultimate on day number 11. Alright? I'll see you tomorrow on day number 99, our penultimate day on the subject of linear equation. We're starting from day number 101. We'll begin our journey on word problems. Alright? Bye now.